Hey, what's going on, folks? It's Mike here, and welcome back to my Deprogramming Language series. In today's episode, we're going to be looking at member function attributes, or method attributes, such as things like const, immutable, and scope. And if you're coming from a C++ background, this is going to be a relatively familiar feature. If you're not, this is going to help you write safer code. It has to deal with something known as const correctness in other languages, but it's also just about marking your data as read-only. So with that said, let's go ahead and take a look at a few familiar things and some things that are going to be new on the Deprogramming Language website here. So with that said, let's go ahead to the documentation, the language reference. I'm going to go down here to classes. Let's give that a click here. Let's just minimize this, and I'm going to go to member functions, aka methods here, so we can see what this feature is here. Now, immediately what we're going to see here is that this code sample down here is what I'm interested in. So this is bullet point number 2. We know about classes and structs, and again, everything that I'm going to actually talk about today is, again, equally applicable to classes and structs. But we know if I have a non-static member function, we have the this parameter, so we know if we're talking about like the internal instance. So that's what bullet point number 1 is about. But again, we're focused on number 2 here. It says non-static member functions. So most of the functions that you usually write for a class or a struct can have an additional to the usual function attributes, const, immutable, shared, in-out, scope, or return scope here. Okay, and there's a few examples here. We're going to talk about the first 2 or so here, just to get us started. And what are the other function attributes? Well, we've talked about some of these previously, things like @safe, @system, user-defined attributes, and so on. So those are the types that you can have here. But what about these additional ones? And these ones you'll notice on our member functions we usually put at the end. I'll talk about why we do that here. So here's a scope one and an @safe annotation as well. But basically what these do is make our code a little bit safer here. So if we're just looking at this example here for class C, there's a member variable A here. And if I mark as a function attribute here for this member function, it has const here, this is going to give me an error here. And basically what const is saying is any member variable that's part of this class can't be modified, right? It's read-only. So it's a quick way to mark all of your data as read-only, and it ensures that, whatever this member function is doing, that you're not going to mutate the data, okay? And this could be common if you have like a return value type of function, or if you're printing this class as a string, for instance. So that's the idea. We can do the same thing with immutable, as well as scope. And we've talked about some of these attributes throughout this series, so you could review that. Scope is an interesting one here in that it's telling us that we don't want to return something that could escape the lifetime, right? So the scope of all of my member variables, I can use them here, I can mutate them, but they must not escape, meaning I can't just like return this, which is the internal pointer to the object here, but I couldn't return like A here for whatever reason, if I was returning like the reference to it or a pointer to it, for instance. So let's go ahead and try this out. Let's just play with this code a little bit here. I'm going to use class for now. Maybe I'll switch it here. And let's just go ahead and say we have some object that we're creating here. Let's give ourselves some member variable. We could go ahead and say, data, maybe is a better name for it. And let's just go ahead and kind of recreate this example just so we can see what happens here. And let's say that we have something like int func1, and I want to return data. And let's go ahead and kind of set up this example here. So let's go ahead and create an object, new object type here. And I'll call func1 here. Okay, just to get us started here. And again, no problem here, okay? And it might be nice to, if we just store this result here, and let's just write out our result. Let's just go ahead and do this. There we go. Okay, just so that we can see that things are working. And it's kind of nice maybe if we initialize this data here, just so we have something interesting to take a peek at here. Okay, so that's the idea here. Now, in order to make this a little bit safer here, let's say, what if I have const here? Right? And let's rename this function to be something better here. So I'm going to rename func1 to get data. Okay, something like that here. And we'll run this program. It runs just fine. But you never know. Let's say this is a larger function here, and someone all of a sudden just says data equals 7 for whatever reason here. We would want to catch that, okay? And again, it's unlikely in this type of like getter setter function that someone's going to do that or make that mistake. But again, you can just prevent that by just saying, okay, const data equals 7 here. It says cannot modify this data in const function. Okay, so what that means again is can't modify any of these member variables here. So again, that can be handy here. And again, you can actually put the qualifier in front. So let's go ahead and put const here, for instance, and I'll give you the same, message here. That's a little bit different than if I did this here, okay, which returns const int here. So again, that's why usually you put the member function attribute here at the end, okay, for like things like const, immutable, shared, in, out, scope, or return scope. And again, when usually you make something const in D, you wrap it in parentheses. You don't always have to, right? You can declare your types as like a const int, but if you check my video on const earlier in the series, right, I recommend instead of doing, something like this, you always wrap it in parentheses, and then it's clear what you're doing. And this is clearly saying this is part of the return value, okay? And the reason for that is just to, have a little bit more consistency in the language so that if you want something like this, right, and then you could put the const attribute as follows, then you'll still get your error message as you expect, because const applies to making all of the member variables read-only within the context of this function. Okay, so hopefully that makes sense, this idea. Again, const, it's best if you put it after here just to avoid confusion, and then you want to make sure your return type is just one clear value here by using parentheses. Okay, if I do this, this is redundant. Okay, so again, just to be clear here, redundant attribute const is the same thing as const here. Okay, if you're coming from C++, this is going to be pretty familiar because you always usually put the attribute at the end like this. So there you have it. Okay, all right, so we like that. That's a good thing here. In D, you also have like, let's go ahead and do in out, which we talked about this in previous video here. And in out is basically going to give us the const immutable and the immutable version of our function. So let's see if we can also make this work. I mean, in out's going to tell us, I have a version of this function that I can't get to. Let's see if I wrap in out int here, if I also get the immutable version here. Let's see, doesn't look like it is going to be super happy with this, right? Because, well, the point of in out is to show us that the code that's generated by this is basically the same whether I'm returning immutable, const, and stuff. These are things that the compiler enforces, right? I mean, at the end of the day, in the assembly code, there's no like const type of thing or whatever. It's just data. So that, I mean, that's one important thing to understand here. So again, so in out is something that we can use, which is again going to be useful for us. Like if we wanted to change this return value to get the like const, immutable, or int type here. But again, this is saying, yeah, we're expecting the same code for the mutable version, the const version, and the immutable version. So can't quite use it here if I am modifying something, okay? But if I'm not modifying anything, oops, let me go ahead and let's redo this here. And we'll just have the proper thing, okay? This version here, for instance. That will give us the version of the code where I can just take the int, I can have the const int version, and I would have the immutable int result version here. Okay, get data here. Okay, and now I need to change these to results 1, 2, and 3, just so we don't get any errors. And 1, 2, and 3. Okay, so something like that here. I mean, the result's the same in this particular case, but we have the int, const, immutable int. So that's just a reminder about what in out is. Okay. All right, so let's continue looking at this. So, I mean, between const and immutable, or in out, right? If I substitute in out with immutable, right, this gets us the same idea here. Let's actually run this. I should get a, I think I'll get an error here for the immutable. Yeah, let's just keep it as this one here. for now. Let's see, immutable. Let's see. And the thing again I like about immutable is it is super strong, right? So again, this object needs to be immutable. So that's why we're getting that error there. So again, kind of a nice thing here. Again, I like immutable in the language, really, really nice, especially when you get to writing concurrent code. Okay, so anyways, we've got this version. We've got the version here. I could write something like this, which would also work. Okay. And let's see. Now I want to talk about scope here, which I think we've talked about scope a little bit in this series here. But again, it's kind of nice here. Let's just give ourselves a new member function. We're just going to call this, and I might actually give us another object here. Object 02, this new object. And let's call it, I'm just going to put it in like a string here. Actually, let's do something more interesting. Let's just put it at like pointer here. I'm just going to call it like underscore underscore pointer. I don't know, something that looks kind of like it's hidden. And then we're going to do like a get pointer type of function here. And let's return that pointer. Okay, so let's just see if this is working to start here. So I'll call o2.get pointer. So let's make sure that compiles. So nothing too crazy here. But again, you might say over time here, and let's hide this just so we can get a little bit more on the screen here, that you're fine with folks maybe modifying the pointer here. So let's just say like pointer equals new, int or something. Underscore underscore pointer. Sorry, let's be, good about this. Okay, so we could do something like that, which is fine. But maybe I actually don't want to return this internal pointer here. So let's use the scope attribute here. And, well, let's go ahead and just, again, recompile this here. And you'll say, hey, that's not exactly matching this example here. Okay, so let's kind of see some other pieces to it. Okay, we got this other thing here at safe, this attribute here, which at safe code has some additional protections here. Okay, so let's go ahead and try this. Compile it. Still compiling, still not matching the example here, but the example is showing there's an error here. So, I mean, let's talk about exactly what's going on here. There's actually some safety stuff coming to D here. I guess it's still being finalized here. But there's something called the D improvement proposal. That's what DIP is 1000. And that enables some more of these safety checks here. So now if I run this, let's go ahead and, let's go ahead and make this an example that leaks this here. I mean, this is still returning just a copy of this pointer here. But let's say if I did something like return the reference to this thing here, okay? So now the scope pointer is kicking in and it's basically saying, hey, I'm effectively, anything that I'm returning here that is like this dot pointer, which is what I have here, it can't be returned here, right? Which is effectively the same thing like if I'm just like returning this object here, okay? So we could, change this example around just a little bit to like do something like this. Let's just put the actual type here. And I'll just call this like get object, okay? Get, and let's just put this here, okay? Effectively the same thing. Oh, now line 28 here. Let's just call get object now. And again, this is basically the same thing here, okay? So again, anything like this dot something or the actual object that's being returned can't do this. And this is something, again, depending on when you're watching this video, you might have to enable with DIP 1000. Maybe this will be something that's just part of at safe in general. So that's something to keep in mind here. Now let's see if I do something like return scope here, which we have learned about, which says that you can, I actually didn't try this here. Let's try this. This is okay here because we're saying, yeah, we can't have other things escape, but return scope is all right here, okay? Now I wonder, again, let's see how good the compiler is going to be if I just create some like global integer thing here. Let's see if I can make this escape here. Let's see if it catches this one here. Global equals, you know, pointer, something like that here. Okay, so I guess that is a way to escape. Let's see, scope. Okay, cool. So it is catching, yeah, this one here. I don't know if it's catching that here for escaping, but maybe that's just my understanding. So somebody can comment below to see, because I feel like this is an example of escaping some internal data when it should just be scoped to this object or something. But anyways, those might be some other things that are coming to these D-improvement proposals here, but just wanted to test that out here. But anyways, if you do see code that has, you know, scope in these types of things here, that's exactly what's going on here. And why it's important to recognize some of these here. One is just for writing safer code, right? It's doing some sort of like escape analysis to say like, hey, you know, is this thing, you know, is a lifetime changing here? That's one part of it. But you are going to see these attributes in the standard library, for instance, or documentation or other people's code. So, you know, we just don't want to be scared of them if we see them popping up here. And that's the idea here. So now we know about these member functions. Now you know about some of the same stuff that is in C++, for instance, like when you see immutable and const, if you're coming from that world in the D language. And if you're not, just a reminder that you have these tools available. So if you have functions that are truly doing member functions, doing truly read-only things, make sure to use, you know, const or immutable as appropriate here. And just another gentle reminder, you know, to wrap, I need to make sure that I get better about this, but whenever you're using const or whatever, just wrap the type in parentheses. It kind of makes things a little bit more consistent. This is usually, again, how you see things in the standard library as well. So it kind of match what you'll read in D's documentation, which is usually pretty useful there. So anyways, folks, with that said, as always, I'll leave you to courses.mshot.io if you want to find this lesson and other cool stuff there and track your progress. Thanks for your time and attention. And I'll be really curious if folks have played around with scope, if you've used it, if it's just too complicated, you know, what your sort of thoughts are. I think it is a neat feature. And again, you don't have to use all this stuff, but it is nice to know that it's there if you do want to get some more checks in your code, for instance. These could be really, really useful attributes. At the very least, I would recommend that folks are using, you know, constant immutable very judiciously or very frequently when you have read-only data. That's just a good habit to get into. And then you got some new things that might be new depending on what programming language you're coming from, like scope, that can be very useful. And of course, the attributes that we've talked about, things like @safe, for instance. Good idea to use that. So anyways, folks, with that, I'll go ahead and end this video. Thanks for your time and attention, and I'll look forward to seeing you in the next one.